Dear students, I welcome you to our topic number 4, statistics. And I want to encourage you to stay home, stay safe, but find time always to progress in your learning as we support you in the different ways that may it be possible. Let's humble ourselves for a word of prayer. Dear Lord, we pray that you will give us wisdom, knowledge, and understanding that comes from you as we take on this lesson. In Jesus' name I've prayed. Amen. Statistics is a concept of concepts, rules, and procedures that help us to organize numerical information, understand techniques underlying some decisions that affect our lives, and also to inform our decisions. You can inform decisions based on what has transpired, for example, and how you spent your pocket money in the previous term. It can inform what amount you need this term and how better perhaps you can save, and how you have spent or your expenditure in this COVID season can inform some wise decisions on how you need to cut down on this and that. And statistics really helps us in management. For example, just like you have seen the president's address he has been referring so much to the statistics of our country here and also our neighboring countries and globally. Relating the different issues helps us to have a picture that is informative for various important decisions. Statistics helps in determining the existing position of per capita, income, unemployment, population growth rate, housing, schooling, medical facilities, and pandemic spread such as the COVID-19. It is a vital tool in fields like industry, commerce, trade, physics, chemistry, geography, economics, mathematics, biology. And that's why in your combinations, some of you have this as mandatory. Either if you are taking economics and yet you're not doing principal math, the ministry saw it fit that you should do some math because it is helpful for you to understand how to project for the future based on what has transpired in the past. Or if you're doing biology and you're not doing principal maths, you need these sub-maths to help you understand some statistical data for your research or to understand certain concepts. Also, for some of you who will go to institutions of learning, you will need these statistics for any kind of research that you will do. You need to acquaint yourselves with these basic concepts of statistics. The most common ways of graphical data representation, like you may have seen in your earlier studies, include bar graphs, the histograms, the frequency polygons, and the ogive or the cumulative frequency curve. Those first four are basically what we will look at for our study here. But you know that in your O-level you looked at the pie charts as well and the pictographs. But we'll mainly focus on the first four. A bar graph or a bar chart presents categorical data with the rectangular bars whose heights or lengths are proportional to the values that they represent. The higher the bar, then the higher the frequency or the higher the number of attributes that are being measured. The bars can be plotted vertically or horizontally, and you will visibly label the bars, and that's why it's called the bar graph or the bar chart. A vertical bar chart, which is the one we shall often use, is sometimes called a column chart. So, like you may see this representation here, perhaps different people were asked which kind of fruits they love most or that are nicest for them, and the higher the bar, it represents that more people preferred that fruit. That is for the vertical bar graph. But if the bars are horizontal, then in that case we can talk of the length. But in our work, I will encourage that we mainly use the vertical bar graph. See that the bars are spaced. I think we'll emphasize that for some reason, as we shall see. as we progress. The histogram is a graphical display of data using bars of different heights, and sometimes its area with different widths. Each bar groups numbers into ranges for equal widths. Taller bars show that more data falls in that range. You need to observe the continuity as we're going to see in the next slide. The bar extremes are mere boundaries. I want to emphasize that for a histogram, it's not just about the length or the height of the bar, but rather the area, because you'll find that sometimes the bars have different widths depending on which classes in the group data that were used. It displays the shape and spread of continuous data. So that's a histogram. As you may see in the left graph, the bars have equal width, but in the right graph, there is a variance in the width of the bars. That's why I said histogram considers more of the area other than just the length. You need the area to actually know how many people or what is the frequency in that particular range of data. The histogram, when we are plotting it, we use frequencies on the vertical and then boundaries on the horizontal. And I want to explain something here. When you look at the left, you have a column that shows classes or bins. Those are class limits, 30 to 39. Those are class limits. Our next class has 40 to 49. Now this is age in years, 50 to 59. But you realize there is a gap in each of those intervals. From 30 to 39, we are going to 40 to 49. But there's something like somebody may have 39.4 years. So there's that gap there. And on the right hand side, you can see 40 minus 39 shows that gap, which should be left when you're drawing your bar graph. But then for the histogram, that gap of 1, that 1 year is divided by 2 to create a boundary, such that when you're drawing the histogram, there is no space in the bars. The extreme of the bars just provides that boundary. Now, some people cram that I should always add 0.5 and subtract 0.5 to create boundaries. That's why I am showing this second stage, that it depends on which kind of data you have. If we had, for example, 4.0 to 4.9 and 3.0 to 3.9, you realize the gap in the bars will be 0.1. And that 0.1 divided by 2 gives you the 0.05. So for you to get your boundaries, you will add 0.05 and subtract 0.05. Emphasis on the non-uniform classes. We use the frequency densities on vertical scale given non-uniform classes. Frequency is calculated as the area of each bar for a particular range. I've mentioned that. So when we are drawing a histogram where we have the non-uniform classes, we use that formula that frequency density is given by the frequency in that particular range divided by the class width of that particular range. I hope you know how to calculate the class width. You might subtract the limits and then add the gap that we saw in between the ranges, or you may just subtract the boundaries and you'll be able to determine what is the class width of that particular range. Still on the emphasis of the non-uniform classes, we have this example here. You can see the graph has different widths for each of the bars. You can study it further. The frequency polygon, a graph constructed by using lines to join the midpoints of each interval, class, or bin. The heights of the points represent the frequencies. Now, a frequency polygon can be drawn by having on the vertical axis, you have the frequencies, and then on the horizontal axis, you can have the class centers. But on the other On the other hand, you may choose to superimpose it over the histogram. That's an example where we have the class centers plotted on the horizontal and then the frequencies on the vertical. And there we're trying to show how the frequency polygon can be superimposed over the histogram. You can see that in all this we are trying to show the spread of data using the graphs. And then finally we have the ogive, or the cumulative frequency graph. This shows portions that are added, like the word suggests, cumulatively until you complete your particular population or your particular sample. An ogive graph plots cumulative frequency on the y-axis and class boundaries along the x-axis. Now, whereas we are saying and class boundaries along the x-axis, that doesn't mean that we should label that axis as class boundaries. We actually should label that horizontal axis with what particular attribute was being measured. If it is age, you can just put age in years. But when you're working, you know that you're working with the boundaries. If it is a height, you can put height in either centimeters or meters, depending on what units were used. If it's kilograms or weight, you can say weight in kilograms, but don't say boundaries. The appearance of a cumulative curve in most cases will turn out as in a kind of an S form. And that's an example of the cumulative frequency curve. It keeps adding, and the final vertical value actually corresponds to the total number of the frequency or the number of items that you used. We have this example for the COVID-19 statistics. Of course, this is as at about 4 p.m. today, the 4th of May. And I think this line graph can easily inform someone to tell when did we have the highest number of those that were found to be positive with the COVID-19 and when did we have the lowest. Okay, and that can inform what caused that. Then it can cause different research, and then also decisions can be made. Let's stop this, let's do that. Guidance can be given to the citizens to see how better the country can strategize to overcome this. We have had 89 confirmed cases and 52 recovered. God's blessing has still been that we have 0 deaths. Stay home to remain safe. And now, here we have a practice for you. You will try to do these two numbers. There are two numbers. You try these graphs. Let us practice the bar graph, the histogram, and the frequency polygon, and also the ogive. This first one has equal class widths, as you will see, but then the second one, it has varied widths, and I hope you'll be able to remember that formula for calculating the frequency density and use it to plot your histogram. I'll be looking forward to see what your submissions will be like. You can submit either by WhatsApp, or Facebook, or Twitter. You can also choose to email educansobis@gmail.com. Our next class will focus on measures of central tendency. Stay safe, stay home. God bless you. Thank you.